Okay, good morning. All right. I already forgot what I was going to say. I don't know. But happy Friday. 6 weeks down. Right. If you didn't get a chance, check out the video from yesterday. There's a lot of important AP information in there. I also sent you a bunch of files that has all that information, but it's a lot longer to sift through with the 50-page slideshow, but still do read through that. And we're going to just kind of get back into practicing stuff. I will keep updating you things as we go along. I'll remind you that on Monday, May 4th, is when you're supposed to get your AP confirmation, and the demo will be available for you to go into the AP website and check out. So log into your My AP anyways, just to check your contact information, make sure that they have your correct email address, make sure that you've checked the box that says you want updates from them, just so that you make sure you're getting all the information communicated to you from AP as well. Good morning. Yep. But other than that, so AP exam is the 12th, right? So not too far away. So we'll just keep doing, random practice FRQs that I can find. This one was this was made by the same person that made that those last two questions that we had. And they went through and they changed their question too, and they updated it. So here's a different one. So I figured that would just be another one to practice through. Has a lot of good stuff in it. It varies a lot of the content of things that we've done over the course of the year. It combines AB, BC stuff. So let's work through it. Good morning. You beat him today, Hayden. Okay. So, for this question, so we're given this graph. I immediately note on this graph that this is a graph of f prime. The function f is twice differentiable with f of 3 equals 7. I bet I'll need to use that initial value at some point. The graph of f prime is shown above. For 1 to 6, oh, interesting. For 1 to 6, f prime is a line segment. That's good to know. So that tells me from 1 to 6. So from here to here, obviously not the line that I drew, but the line that's on the graph, it tells me is a line segment. So that is a straight line. That might come into handy later. Maybe if they asked me to determine a specific slope or maybe some area stuff. I don't know. So let's see. But I feel like that'll be important since they went out of their way to tell me this is a line segment. Function h is not shown above, but the function h is defined by h of x equals 2x minus 5. So just kind of a basic formula right there. So that's good. Okay, part A. I don't know how much we'll get through today. Maybe through the whole thing. I think it's through part E. I don't know. Maybe we'll cut it short. We'll see. Let g of x equal f of x squared minus 1 times h of 2x. Okay, so now I have this separate function g that is built by using f and h. Find g prime of 2. Great. Well, the first thing, before I find g prime of 2, I just want to find then what is g prime. All right, well, take a look here. So I'm trying to take the derivative of two functions that are being multiplied. It keeps buffering. Is that just Hayden? Is Hayden just getting the RJ internet, or is everybody's kind of rough? Because it could be on my end. Just Hayden. Sad. Rip Hayden. All right, so I want to take the derivative of g, so that's made up of these product of two functions. So if I'm taking the derivative of a product rule. First times derivative of second plus second times derivative of first. Gosh, that's a surprise. So the first function is just f of x squared minus 1. Derivative of the second, so the derivative of h would be h prime. But chain rule, because there's two x's inside that, so h prime of 2x, and then times the derivative, so times 2. Okay, so that's my first term, plus second times derivative of the first, so the second function is just h of 2x, times the derivative of the first function. The first function's derivative is f prime of x squared minus 1, and then chain rule, multiply by the derivative of the inside, so the derivative of x squared minus 1 is 2x. All right, so here's my equation for the derivative. Now we just have to go in and plug in 2 and do some evaluation. So g prime of 2, so f of 2 squared minus 1, so 4 minus 1, so f of 3, times h prime of 2 times 2 is 4, and then times 2, plus h of 2 times 2 is 4, times f prime 2 squared 4 minus 1, so f prime of 3, and then times 2 times 2, 4. Okay, so we should be able to figure out all these pieces because, think about it, f of 3 we know from right here. That was one of our initial values. H prime, it just tells me h, but look, h is just, I have an equation. So if h is 2x minus 5, h prime of x, derivative of 2x minus 5 is just 2. Okay, great, easy. H, I have an equation for h. F prime, I have a graph for f prime. So I have everything I need that I can just plug in values and get my final answer. Right, f of 3 is 7. Right, that was what it was. Yeah, f of 3 is 7. H prime of 4. So here's h prime. If I plug in, oops. Can you guys see that? And move it over here. Right, this yellow equation is h prime. So if I plug in 4, well, h prime is still just 2. So times 2, and then times 2 again. Plus h of 4. So if I go to my original equation, h, 2 times 4 is 8. 8 minus 5 is 3. F prime of 3. So here's f prime. Here's 3. That would be 2. And then times 4, so times 4. If this were the AP test, leave this right here. You don't, I mean, this is an easy thing to calculate, but you don't need to. Leave it here. I'll go ahead and do it. 7 times 2, 14. 14 times 2 is 28. 3 times 2 is 6. 6 times 4 is 24. Uh, 28 plus 24, 52. So Final answer is 52, but your AP test answer, you can just leave it right here. Don't need to simplify once you just have numbers. Okay, so there's part A. Is really just using the product rule and chain rule. Just plug in values after that. All right, part B. So same setup, but part B now asks, given that the integral from 2 to 4 of f prime of h of x is 22/3, find f of -1. Interesting. Okay. The integral from 2 to 4, f prime of h of x equals 22/3. Find f of -1. Okay. So let me kind of expand this integral here. Now remember, I already know what h of x is. H of x, the problem tells us, is 2x minus 5. Okay, so if I actually wanted to take the antiderivative, or the integral of this, the antiderivative of f prime is f. Okay, but since there's the 2x minus 5, I have to think, what would the derivative of 2x minus 5 be? Well, that derivative is 2. So I should have a 1/2 in front to help cancel it out whenever I would need to do the chain rule, taking the derivative. And then from 2 to 4. Right? Okay, so that equals, I'll just leave that 1/2 in front. So if I plug in 4, 4 times 2 is 8, 8 minus 5 is 3, so that would be f of 3 minus, plug in the lower bound 2, 2 times 2 is 4, 4 minus 5 is -1, so f of -1. And interestingly enough, I now have an expression that has f of -1 in it, and that's great because that's the thing that I'm trying to find. And the even better part about this is that I already know what this integral equals. This integral equals 22/3. So now I have an equation here that I can use to solve for f of -1. Okay, so the first thing I'm going to do is multiply both sides by 2 so that that gets rid of the 1/2. So then I would be left with f of 3 minus f of -1 equals 44/3. Let me rearrange this equation. So I'm going to move this to the left side, and then I'm going to move my f of -1 to the right side. Because again, remember, I'm trying to solve for f of -1. Okay? Don't forget, f of 3, we already know what that is. We are told from our initial value that f of 3 is 7. So 7 minus 44/3 equals f of -1. 7 minus 44 thirds. So that would be 21 thirds. 21 thirds minus 44 thirds. So that'd be minus 23 thirds. But if you're on the AP test, just leave it as this. Don't even need to worry about it. Again, that's not that that's a difficult fraction to do. You know, not that it would take you a ton of time, but still, don't take the risk of making a simple mistake. No offense, but you guys know just like how easy it is to make such a simple mistake. I make those mistakes all the time of just like forgetting a negative or accidentally adding when I was supposed to subtract or something stupid like that. So don't take the risk. So there's part B. Part C. So same setup. Given that the integral from -1 to 1 is 40 thirds, evaluate -1 to 5 f double prime of x times h of x. Okay. Interesting. Very interesting. All right, so I'm looking at this. I think what's going to happen yeah, I think so. So remember, so back in part A, we were trying to find the derivative of a product. So we used the product rule, right? The derivative rule, the product rule for derivatives. First times derivative of second plus second times derivative of first. Okay, so now I have another product, but now I'm taking the integral, right? The antiderivative. Okay, so what's the rule for that when we're doing integrals of product of two functions? That's probably when we're going to have to use integration by parts. There's no, our other option is maybe can we try a u substitution that by taking u equals one of these things, would the derivative equal the other thing? So it would substitute nicely, but h and f double prime are not related to each other, right? H is not made using f, f is not made using h. These are just two separate, distinct functions. So I'm going to need to try integration by parts. Right, so that formula, we talked about that yesterday. Oops, I already screwed it up. Integration by parts always gets me. I always have to really think. uv minus the integral of v du, right? I'm almost certain. So we're going to need to make a choice. Which one is u and which one is dv? Well, remember, so that sometimes what we have to do is just kind of guess. We say, I don't know which one's better. Let me just try. We can often, though, have a little bit of intuition about which one should be better. So, for example, think about u and dv. U, we're going to have to take the derivative of. dv, we're going to have to take the integral of, or the antiderivative of. So ask yourself, which of these would be better for taking a derivative? Which would be better taking an antiderivative? Well, if I think about it like that, then I would want to make this choice. Now, why do I do that? Because when I take the derivative of u, I'll take the derivative of h. Well, I know what the derivative of h is, right? We already did that. We have an equation for h. That's easy to find the derivative of. And then when I take the integral of both sides over here, the integral of f double prime is f prime. Well, and while I don't have an equation for that, I have a graph for it. Okay, so making this choice for u and dv means that I'll end up with functions that I can work with, right? Otherwise, if I switch this, if I took the derivative of f double prime, well, now I'm at f prime prime prime, right? The third derivative of f. I don't have any idea what the third derivative of f is. Right? I can determine some properties of it based on this graph, but not a lot. And then if I had to take the integral of h, I literally, okay, we can do the integral of h here, but it still doesn't work out with both. Right? So this should be our better choice to make. So let's take the derivative of u. So du equals h prime. H prime we decided is 2. So that's 2 dx. All right, we always get the du dx on the left, but then just multiply the dx over to the right. Take the integral of both sides. So that's v. Antiderivative of f double prime is f prime. Okay, so these are two things I can easily work with. And actually, here, let me be a little more clear in what I'm doing over here, just for the sake of reminding us how this goes. So du dx equals 2, because h prime is just 2. I'm going to move the dx over to the right, and I'm going to move that 2 over to the left. Now let's plug everything into our equation here. So this integral equals this, which equals this. So u times v, h of x times v. So h of x times f prime of x, and that's evaluated on our bounds, so -1 to 5, minus v du. So minus the integral of f prime of x times du, which du is, well, du over 2 is dx. Okay, so I'll have that 1/2 in front. Wait a minute. Hold up. That's the wrong way to think about it. Okay, now that's fine. Du over dx. But actually, I'll leave that 2 over here. Because when we're doing integration by parts, we're not substituting for dx, we're substituting for du. So du is equal to 2 dx. So this would be 2 dx. Make that a little prettier. Right? Usually we go from I have dx, and now I'm substituting what is equal to dx. But that's not what's happening here. Is we have du, so we're substituting in what is equal to du. So we solve for du. So du is equal to 2 dx instead of solving for dx. Right? And this is also from -1 to 5. Okay, so we can just straight up evaluate this first part. So h of 5 times f prime of 5 minus h of -1 minus h of -1 times f prime of -1 minus 2 times the integral of -1 to 5 f prime of x dx. All right, so before I deal with this stuff, let me just evaluate this stuff. H of 5, so reminder, so I don't have to scroll back up. H of x equals 2x minus 5. So 5 times 2 is 10. 10 minus 5 is 5. F prime of 5. Oh, I have to scroll back up for the graph anyways. Here's f prime. F prime of 5 is negative 2. Minus h of negative 1. 2 times negative 1 is negative 2. Negative 2 minus 5 is negative 7. F prime of negative 1. So here's f prime of negative 1. Positive 5. Minus 2 times, okay, now let's think about, we got to be smart here. So I'll go ahead and tap out. The integral from negative 1 to 5. Now, I do not have an equation for f prime, right, for the antiderivative, so I can't actually algebraically figure out the antiderivative and then plug in 5, plug in negative 1. All right, but I do have some key information. So think about what else does an integral represent. It represents area under the curve. So this represents, and I have a graph of f prime, so maybe I can literally calculate the area from negative 1 to positive 5. So let's go back up here. So the area from negative 1 to positive 5. Do I know what all of this area is? Well, at the moment, no. But here's a couple things I do know. I do know from negative 1 to 1, the area is 40/3. Okay, so from here to here, that area is 40/3. So my only question then is, all right, well, I already know that part. I know negative 1 to 1. So now what is it between 1 and 5? All right, well, I've got good news. Remember, this is a line segment. This is a straight line. So what that means is we can easily calculate this area and this tiny area down here because they're just triangles. All right, so let's first go from here to here. I know it's a really good picture. So this area, 1/2 base times height, so that's 4 times 6. So that area is 12. And then this area from 4 to 5, one-half base times height. So the base is 1. The height is 2 because it goes down 2. 1/2 times 1 times 2 is 1. So my total area under the curve from, and actually more specifically, that's not positive 1, that's negative 1, since this triangle is underneath the x-axis. All right, so my total area is 40/3, that's the pink part that we were already told from the beginning, plus 12, this blue triangle, and then minus 1, that purple triangle down there. Minus because it's below the x-axis. All right, and that goes, so that takes the range we wanted from negative 1 to positive 5. So this integral is 40 thirds plus 12 minus 1. Now this is gross, but who cares? So this is a spot where, yeah, you definitely would just want to leave it right here. Right? I would not want to waste the time going through and getting common denominators and doing the math and adding and subtracting things together, and there's so many opportunities to mess up a negative sign or a plus sign or whatever. Leave your answer like this. You get no credit for continuing on to simplify this. None. Okay, even if you do everything perfectly right, leave it here. I guess I should be clear. That's kind of a bad 0. So always consider if you're given a graph and if you need to find the integral of whatever function that is being graphed, can you just straight up calculate the area? Even if you don't have an equation for it, could you just find the area by using triangles or by using area of a circle, or maybe it's a semicircle, or maybe it's just a quarter of a circle, whatever. But use information that's given to you at the start in combination with, can you calculate an actual area on the graph? Because you might have to do that. Okay. So there's part C. Let's do part D. Oh, jeepers. Okay. Part D. Evaluate the integral from 1 to 2 of 6x over f prime of x times h of x dx. Yikes. Okay, so I want this integral. Now, since I'm looking at the denominator and I see a product of two functions specifically in the denominator, and again, there's no way I can make a u substitution here that would somehow get rid of all of those pieces, the h of x, the f prime of x, and the 6x. I've got nothing. Okay, so my next option would maybe do integration by parts, but that seems a little more complicated because I have like 3 different pieces, right? The 6x, the f prime, and the h. So what really clues me in when I look at this is that there is not only a denominator, but there is a product in the denominator. And so when there's a product in the denominator, what I'm thinking is that I'm going to have to use partial fraction decomposition. Remember, partial fraction decomposition takes stuff in the denominator when there's multiple things being multiplied in the denominator, and it splits it up into fractions where there's only one piece in each denominator. And that makes it a lot easier for us to integrate. So I think I'm going to need to split this up using partial fraction decomposition. Okay, so let me first do that. Before I even worry about the integration part, I'm just going to use partial fraction decomposition. So 6x over f prime of x, h of x. I'll have 2 fractions that this will decompose into. That is because I have 2 factors, f prime and h. So one of my denominators will be f prime, one of my denominators will be h. And what will the numerators be? I don't know. So we just call that a and b. Right, this is the start of our setup just for the partial fraction decomposition. We're not even worried about the integral yet. Let's take our whole function, or our whole equation, and multiply it by the LCD, which in this case is just f prime of x, h of x. So this entire denominator on the left will cancel, leaving me with just 6x. For a, the f primes will cancel, but there will still be an h, so a times h of x, plus, for this term, the h of x's will cancel, but leaves me with the f prime, so b times f prime of x. And I'm going to go ahead and actually substitute, since h we know is 2x minus 5, so I'm going to do 2x minus 5 here. F prime we don't have an equation for, we just have a graph for. Okay, so normally we would distribute, we would organize the x stuff together, organize all the constants together, and then set a system of equations equal to the left side. But for f prime, we don't have an actual equation, right? We just have a graph. So I'm going to teach you another trick that you can do. I think we might have talked about an example like this earlier, like when we did this earlier in the semester, but I can't remember. Maybe. But here's another trick for what we can do for partial fraction decomposition. Is we can figure out where each term will be 0. Okay, and then evaluate our entire equation at that point. So for example, looking at this first part, 2x minus 5, where is that going to be 0? When will that be equal to 0? Well, I can just solve that, right? Add 5 to both sides, divide 2. So x equals 5 halves. So at x equals 5 halves, I would have, so I'm just going to plug in 5 halves everywhere. Right? 6 times 5 halves, so that would be 30. 30 divided by 2, so that would be 15. A times, if I plug in 5 halves here, I'm going to get 0. So this term just cancels. Right? But B times f prime of 5 halves. So f prime of 5 halves, let's see. So 5 halves is 2.5. Well, by golly, that's exactly at 3. So this is 3b. Divide both sides by 3. So I get b equals 5. Okay, next up, I can think about where is f prime, where is this term going to be 0? So where is f prime equal to 0? Where does that happen? Well, let's just go straight up to f prime. Right? It happens in a couple spots, but for this question specifically, we're talking about from 1 to 2. Or actually, no, hold on, sorry. That would be a different part. So I have different options. Right? We have f prime 0 right here, f prime 0 right here, f prime 0 right here. Right? It doesn't matter. I'm going to choose 4. Why am I going to choose 4? Because I don't know what these values are. These are some sort of decimal or fraction that I don't feel confident saying, oh yeah, it's most definitely 9.178. I don't know. But this is exactly at 4, so I'm going to use 4. So at x equals 4, so I'm just going to go use this equation and plug in 4. 6 times 4 is 24. 2 times 4 is 8. 8 minus 5 is 3, so that would be 3a. Plus b, f prime of 4 we know is already 0, so that term would just cancel. And I just have a nice equation here. 24 equals 3a. Divide both sides by 3. So a equals 8. Okay, great. So I have my constants. A is 8. B is 5. So my integral transforms into integral from 1 to 2 of, well, here, let me write the whole thing just so it's clear to see. So I'm going to move it over to the left. Okay, 1 to 2, 6x over f prime of x, h of x, dx. All right, and we determined that that is equal to 8, because we got 8 for a, over f prime of x, plus 5, because we got 5 for b, 5 over h of x, dx. And again, still 1 to 2. Bounds don't change. All right, now since I have to take the integral, let me actually go through and plug in. The other thing I'm going to do is, because we know one of the rules of integration is if I have an integral of something plus something, I can split that up into individual integrals. Okay, so h of x we know is 2x minus 5. F prime of x, we were never given an equation for that, but I can figure it out. All right, let's go back up to here. Look at this. I have an equation that I could just solve for f prime, especially since I know what a is and I know what b is. Okay, so I'm just going to, a was 8, so 8 times h of x, which is 2x minus 5, plus b, which is 5, times f prime of x. I can just solve this for f prime. Let's do it. 16x, distribute 16x minus 40, plus 5 f prime. So negative 10x plus 40 equals 5 f prime. So I just subtracted 16x from both sides, added 40 to both sides, and now let me just divide by 5. So negative 10 divided by 5, negative 2x, 40 divided by 5, plus 8. I guess I don't want to box it. It's not like my final answer, but you know, it's important. I have an equation now for f prime. I didn't originally. Right? And now hold on. Are we sure this works? Yes, because we're doing this from 1 to 2. So look, f prime is just a linear function. Now this entire graph is not a linear function, right? How could that equation create this curve? Well, it doesn't, but it does between 1 and 2 at least, right? This is the straight line that the problem setup talks about. It's a line segment. So this is f prime, more specifically just for that straight between here and here, wherever the straight line is. Where does it talk about that? Yeah, between 1 and 6. But that's fine because the integral that I'm doing is between 1 and 2, so it falls within that range. Right, so actually f prime of x is negative 2x plus 8. Right, wasn't that what it was? Negative 2x plus 8, yep. All right. When we do partial fraction decomposition, we pretty much always end up with natural log integrals. Right, so remember the antiderivative of 1 over u is natural log of u. So this would be 8 natural log of negative 2x plus 8. But I have to consider the chain rule. So times negative 1/2. Okay. And then here, so 5 natural log of 2x minus 5. And consider the chain rule. So derivative of 2x is 2, so that would be 1/2. And remember, though, we're evaluating both of these from 1 to 2. So we still have a little bit to do. 8 times negative 1/2 is negative 4. Negative 2 times 2 is negative 4. Negative 4 plus 8 is positive 4. Plus 1/2 times 5, 5/2. Natural log, 2 times 2 is 4. Four minus 5, absolute value of negative 1. Okay, so this is all just from plugging in the upper bound too. So then I subtract and plug in the lower bound. Right, so again, negative 1/2 times 8 is negative 4. Negative 2 plus 8, this would be natural log of 6, plus 5/2. Natural log, 2 times 2 is 1. Or sorry, 2 times 1 is 2. 2 minus 5, so absolute value of negative 3. And again, while this is very gross, this should be your AP test answer. I would not go through and try to simplify. Okay, you could, but I wouldn't recommend it. I think maybe the most that you could, if you wanted to, is do the absolute values. So this is actually just natural log of 1, or absolute value of negative 3. So this is actually just natural log of 3. You could do that. And interestingly enough, natural log of 1 is 0. Right? So absolute value of negative 1 is 1. Natural log of 1 is 0. So actually that term is gone, because that term is just 0. But if you entered it as natural log of absolute value of negative 1, that would still be a fine answer. But that term does turn out to be 0. Where we at? Part E. All right, let's bring it home. The function k has the first derivative given by k prime is f of x plus 2. All right, that'll definitely be important. It is known that k of 1 is negative 1. Definitely important. Third degree Taylor polynomial centered about x equals 1. Okay. So, P3, third degree Taylor polynomial. Right? First derivative given by this. Okay, so this is a Taylor polynomial for k, whatever the function k is. So k of 1 is my first term. Right? The first term of a Taylor polynomial is always just the original function, and then you plug in wherever it's centered around. Okay, plus, so now starts our pattern. K prime of 1 divided by 1 factorial times x minus 1 to the first. Now there's a lot of 1's here, but remember, what is the pattern coming from? These are the ones that are the same because of the pattern, because of the equation. This 1 comes from it being centered around 1. All right, those are different 1's. Plus k double prime of 1 over 2 factorial times x minus 1 squared, and then plus k triple prime of 1 over 3 factorial x minus 1 cubed. Okay. So let's kind of do some simplifying. K prime of 1, so that just means I plug in 1 to this equation, right? F of 1 plus 2 is 3, so that would be actually f of 3 over 1 factorial, so that's just f of 3 times x minus 1 plus k double prime. Okay, so wait a minute, what is k double prime? So the derivative of this, that would equal f prime of x plus 2. Chain rule, derivative of x plus 2 is just 1, so it's times 1. I don't really need that. Okay, so that's actually f prime of 1 plus 2, so f prime of 3 over 2 factorial is 2 times x minus 1 squared. All right, and then k prime prime prime, so that's the second derivative of f, and chain rule, but again, that's just times 1. So f double prime of plug in 1, so that's f double prime of 3. 3 factorial is 6, 3 times 2, and then times x minus 1 cubed. Okay, so I've got a lot of kind of change of what I'm looking at here. Oh, and another thing, I already know, I was kind of worried for a second because I was like, wait a minute, how am I going to know what k of 1 is? Because k prime is f. So if I wanted k, I would take the integral, but I don't know what the integral of f is. But it tells us the initial condition that k of 1 is negative 1. All right, so that helps. All right, so negative 1 plus f of 3. All right, well, hey, check it out. Remember, we used that earlier. F of 3 is 7. So 7 times x minus 1. F prime of 3 over 2. So let's go to f prime of 3. So here's f prime. 2. So that would be 2 over 2 is 1. So that's just x minus 1 squared. F double prime of 3. Okay, f double prime of 3. So I'm looking here. What's the derivative of this? Well, I know this is a straight line segment. So what is the slope of this straight line? Well, we can just look like from point to point. All right, that slope is negative 2. It's going down 2 over 1, down 2 over 1. So since, now we can say this because it told us this part is a straight line. So f double prime of 3 is negative 2. So minus 2 over 6, so that'd be 1/3. X minus 1 cubed. And it doesn't ask me to estimate anything or approximate a value. It just says, what is the Taylor polynomial? So there's my answer. Okay, so for all of these parts, I don't think the part that's hard about these is we had to pull a lot of information from different places. I had to use the graph to pull some information. I had to use my equation for h to pull some information, right? And I had to pull initial starting values that the problem just told me I could use. So there was just a lot of different pieces. So it's just being able to organize in your mind, okay, this is what I have to do, but I have to pull this from over here, this from over here, this from over here, right? To and relate the pieces, understand how they relate to one another. Like this last problem, all of a sudden told us there's this equation k. Well, k is based on f. So whenever I take the derivative of k, I'm actually doing some sort of derivative of f or second derivative or something, okay? So it's about relating the pieces together. All right, but that's all we have, right? Yeah, it does go on. Okay, so let me take my daily time to remind you that you should be at home practicing FRQs, even if it's these same exact ones, especially if it's the same exact ones. Practice the process, practice looking at a problem and thinking about what is it that I need to do here, right? Thinking about why the parts, why the steps make sense. How does this graph relate to this equation? How does this, okay. So I think, to me, the two of the most key things are, do you know your equations? Do you know your formulas? Right? Like from that sheet, the stuff you should know cold sheet. Do you know your formulas? And B, are you practicing FRQs? All right, those are the two biggest things. Now, you can also go through and do practice tests of multiple choice and things like that just to practice the skills themselves. But the difficult things about FRQs is it's not just do you know the skill. It's not just do I know how to make a Taylor polynomial. It's can I take these three different equations and relate them together and then create the Taylor polynomial, right? Or it's not, even in part A, it's not just do I know the product rule. It's do I know the product rule and can I use it from pieces of a graph, pieces of an equation, using the chain rule. Okay, so FRQs are all about combining multiple concepts together into one problem. So yes, they usually have like an underlying skill. Like the underlying skill of part A is a product rule, but you have to use the chain rule. You have to be able to relate information from graphs and equations. Okay, part B and C, oops. Okay, same thing. Part C is asking us, can I do integration by parts? But it's not just about integration by parts. It's, can you use integration by parts while pulling some values from an equation, pulling some values from the graph, pulling some values from initial conditions, and using that to relate the information. So that's why FRQs are harder, is because it's not just about one thing. Multiple choice questions are just usually about one thing. Do this thing. Do this thing. FRQs are about do this thing, but you're going to have to use these 4 other things to do that. Okay, so know your formulas. Recognize when do you use a formula. Again, we kind of talked about, like for part D, I recognized I'm probably going to need partial fraction decomposition because my denominator had a product of 2 functions. And I know that's hard to take an integral of, but if I can split it up into individual functions in each denominator, that's much easier to do an integral of because I can use natural log. Right? Or was it this one? Yeah, recognizing I saw I needed to do this integral, but it's an integral of, right, this product of 2 functions. Right? So I know derivative for a product, I use product rule. Integral of product, I'm probably going to need to use integration by parts. Maybe a U substitution could work, but in this case it didn't. So that's why I thought integration by parts. Okay, so know the formulas. Along with the formulas, know how to recognize when something is in the format that you should use the formula for. And then practice the FRQs. Drill the FRQs, do them over and over again. Like I've said, and I will continue to say every day, we have 11 days, well, 11 calendar days, but we have 6 in-class days. Monday, Tuesday, Wednesday, Thursday, Friday, and then the next Monday, and then Tuesday, that's when the AP test is. Okay. So, hope you're doing it. A couple of you I still have yet to hear from. Please, I sent you an email this morning. Please respond to me telling me if you're going to be doing the AP test or not still. Okay, because otherwise I need to get some stuff in motion if you're not. But either way, please respond. You know who you are. And yeah. Hope. Okay, other questions for me? Whoa. Also, again, if you missed the video from yesterday, please watch it. I know it's long, but for those of you that are taking the AP test, a lot of important information in there about steps you're going to need to take in the next week or two. All right. Hit me up with any questions. Guys, go take Taylor and Maclaurin polynomials, that PFA. I'm pretty sure everyone that's taken it so far has gotten 10 out of 10. And quickly, too. It's not a super detailed, involved AFA. Okay, as long as you know your formula for Taylor polynomials, you should be fine. They're pretty basic questions. They're not super, super complicated. But also take all your other PFAs and AFAs as well. If I got a 10 on it, that says something, guys. Come on. Come on. Come on. Right. Okay. Respond to me if you need to respond to me. Keep studying. Keep working hard. Let me know if you have any questions. I will see you guys back on Monday. Later, skaters. Have a good weekend. Get outside. Enjoy the sun.